Well, g'day, Max here again. Welcome back to the shop and welcome back to another episode on our delightful, sexy, gorgeous Dean Smith and Grace lathe. So let's stop effing around and hook straight into it. So the end of the last episode, I think we were working on this backing part of the dial and crossfeed screw support bearing. So yeah, we removed the old broken plate on the front. There's some bit of evidence of the previous repair to my repair. And we machined up a steel plate, got rid of the old disc that was on there and put a new one on. And now we were thinking about, we were going to Scotch key it, but there's no need. It's got a really good press fit on there. And somewhere in amongst that radius, there's a join. It's right there where the material changes colour. So, really happy with how that's came out. If we can get it back in. That's it, goes in there. And there's a grub screw, goes in down the side of it and engages it like the same principle as a Scotch key. It's tapped half into the bore and half into our disc. That locks it and retains it all in the correct position. So yeah, that's that sorted. Now our dial, graduated dial, can go on there now. Little brass spacer washer, hand wheel. Hand wheel still being repaired. We did have to make up another lock, the same as the one for the carriage cross slide. And that goes down in here. That pushes on a plunger. I'll get you a better angle. Pushes on a plunger, which isn't in at the moment. Spreads two pins to lock the dial. Yeah, same principle as the carriage hand wheel one here. So what we have to do now is sort out the hand wheel. Now, the one that came with the lathe is a bit of, well, honestly, it looks like it came off the Pirates of the Caribbean. And this is it here. And my golly gosh, have you ever seen such a crustacean? I mean, you probably catch a disease off it. So if push were to come to shove, I would have to repair this, use parts of the original and make some new parts. But in the interim, I had been searching on eBay, and the nearest thing that I could find was this one here. So the counterweighted section is not too dissimilar from the original Dean Smith and Grace one. It's just the handle here. I don't know why it's not over there. Anyway, I got this from USA on eBay and I do not know what sort of a machine it's off. No idea. So my plan was to use this one here. Now, figuring that if I put this in the lathe and take that square profile out of it and put a full radius profile in there, it would look the part. So all I'd have to do is bore and key the center and this will work. So that's the plan. However, the plan has just recently changed as of a few hours ago. So we're not going to worry about radiusing. Well, I don't know, I might, but we're definitely going to bore it out because I have a lead possibly on another genuine hand wheel, but we'll see if that plays out or not. I'm not sure yet, but it would be good if it did. So yeah, in the interim, this is going to be the one. I think now we can get this in the lathe and get this board out. But yeah, I did the rest of this off camera just to save a bit of time, you know, and the same with the threaded part here. However, the threaded part here wasn't as straightforward as I expected. The thread should be 3/8 diameter, Dean Smith and Grace Special, 22 TPI. Now, someone in their wisdom, for about half the length of the thread, had screwed in a 3/8 UNF tap and changed the pitch. So when I went to put my the other one of these that I've got, the one out of the saddle hand wheel in, it would only screw in a little way and then stop. So yeah, there was two different pitches of thread in there. So I did my best not to molest and screwed a piece of silver steel here, and I cut the 22 TPI thread on it, cut the end of the wedge in the hope that if I screw it in, it'll act like a tap and it may cross over and pick up the original pitches, but there was no way I could get it to work. So I had no option but to tap the remaining length of the hole 3/8 UNF. Therefore, I had to make the thread on here 3/8 UNF. But worked out in the end. All right, not the correct period, correct thread, but 'tis what it is. And that's that. So let's head over to the lathe. We'll get our hand wheel set up and board and keyed. Right, we've got our hand wheel mounted up and it appears to be running reasonably true. All looks good from here. So I'll just run a light cut through and we can determine a size then, and we have to bore this thing out to 19 millimetre. Well, actually 19.04 to 19.05. We'll just get a bit of a measurement now just to see approximately where it is. Uh, 5/8, 16 millimetre. So about 3 millimetres to come out, 1/8 of an inch. And we're just taking small cuts, 20th thou, half a millimetre off the diameter. She's bordering on being a bit of a squealer. Okay, let's just get a bit more of an accurate size. which we can't yet. I'll just get a smaller telescopic. .93 millimeters. Just change our DRO. 0.93. Enter. Okay. Okay, I'll bring you back when we're coming up on size. Okay, my DRO says we're 18.5 and we're still taking 0.5 millimeter balanced even cuts. So we're coming up on, see what our actual size is. Uh, 18.5 right on it. Okay, so because we're taking balance cuts, I can take another 0.5 millimeter 20th thou cut for a finished pass, and that should put us right on. It'll actually bring us just under our finished size. Our finished size needs to be 1 thou above where we're going to end up, so we'll take a chance. We'll just dial in that extra 1 thou this time. So let's wind on our finished cut. So we'll go to 19.04. So that's the lower level of where we need to be. So we'll see how it comes out. So we came out 19.035. That'll be fine. Only 5 microns under our lower limit, so that'll be good. Right, I'll just deburr this edge if I can. I'll drop it down to a slow speed in case we catch that keyway, or the remnants of it. So yeah, I did, before I withdrew the tool out from that last cut, I did back the tool off, as there's a fair bit of tool pressure on it, and that's the main reason why you take a balanced cut. It's to negate that tool pressure. Sometimes with a bearing fit, it's a semi-balanced cut, but I will sort of sneak up onto it a bit, and that's just my way of doing it. If it's a bearing fit and it's got to be, you know, dead nuts on with an extreme tight tolerance, but for general work, balanced cuts are fine. Okay, so all the chrome's coming off this. Don't like that. Let's, yeah, shit chrome job. Might just take a little facing cut across that. Just change tools. Yeah, I just want to remove that chrome that's flaking off. Let's go on the next speed range up, back to where we were. Okay, that's got it off the face. Now we got it on here. Let's just take it off here as well. I don't want to get in there with a file. It's a bit wild and woolly with these reverse jaws hanging out past the job. Just checking to make sure we can get our tool in. We've got plenty of clearance, so. I think that's pretty good there. Okay. So we need to cut a keyway in this now. You know, what I think I'll do, because the chrome's pretty shitty on here as well, I think once we've done our keyway, we'll grip this on an arbor so we can hang on to it. We don't want to be hanging on to it by there because it's not very strong and we need a bit more room. So I think we'll put this on an arbor. We can hang it out the chuck a bit, possibly support it with a centre if required, and I think we'll tackle doing a bit of a radius on here, and that'll get rid of this loose chrome, because it's just itching to cut you, you know. You can see the nickel underneath, and that's starting to come off a bit. So personally, I don't like chrome. I like satin chrome on a machine. But yeah, okay, let's do that. Get our keyway in. So just quick test fit before we do our keyway. Perfect, lovely. Okay, I'll meet you over at the arbor press. If you look in the bore, there's remnants of the old key. So yeah, we'll have to make sure we cut ours in the same position. Right, well, plan A didn't work because the brooch that we need is a size B. That's the shank size. And it won't fit in the guide because the guide is a size C. So, oops. Right, so we need to go to plan B. Oh, and I did pick up some 16mm Dynabolts. So this press can be bolted down once I'm convinced it's safe to do so in this location here. And so plan B was a non-event as well, as none of my tooling, keyway tooling for the shaper, will go down that small. My bar's a bit big for the hole. Right, we need another plan. So the best plan would be to use my little slotting head here on the Bridgeport, but when I fitted the DRO, the cables aren't long enough to swing the whole ram around 180 degrees, as I found out the other week when I went to use it. So, and seeing as I still have to, my plan is to mount that head on Hong Fuck Wong here instead of that thing there, and then use this machine for doing all the small slotting. So that's not going to work. So what are we up to? Plan D, E or F? So we'll set it up in the Bridgeport. I'll get a tool set up and we'll just manually slot this one, seeing it's only a small key. Okay, we got it by the scruff of the neck now. So we should be able to manually slot our keyway through. I've just set it up by eye, and that's close enough for a friggin' hand wheel. So just light cuts, and we'll just feed it in. And hopefully we'll end up with something resembling an internal keyway. At least it's cast iron, so it's pretty soft, this stuff to cut. I think so far so good. And I'm just taking 0.1mm cuts. With a spring cut every now and then. So our slotting tool is bottomed out on depth, so .43. So we're only half a mil shy, but I'm not going to alter that because our tool is a brazed-in tool. And it's a very shallow brazed in tool, piece of tool steel. So that'll be fine for a hand wheel. So I'll just have to file 0.5 millimetre off the key. Okay, so after a bit of filing and fine tuning with our key, beautiful. I don't know if I can get the camera in there. That's our key. So the question now, I think, we're contemplating doing a radius on the end. So I've just been thinking about this, you know how I mentioned, like I just said, to create a full half circle radius on this. What I think would be more appropriate, you know, all right, it's square, it blends in, but it doesn't, if you know what I mean. But what sticks out like dog's balls is why they've got this handle on the same side as the counterweight. Now that is totally wrong in my book. It needs to be here. You know, that's the idea of it, so it's properly balanced. Now if we do a radius, we will not be able to move this handle. So I might remove the chrome and see how it looks, and that way we can unscrew the handle and screw it in here. Would have to go over to the Bridgeport and get a slot drill or something and create a flat surface there for it to screw up on, but I think, oops, I'd be much happier with that look, because to me that just looks wrong. And back to our carriage ham wheel. While we're on ham wheels, we've completed all of the welding. Okay, it looks ugly, but it's done, and it all gets ground back. So I'll get this all prepped and ground back, smoothed off, and then see how it comes up. So far we're looking okay. But as it's Sunday afternoon, 12 o'clock, I might knock off for the day and try and fire up my ride-on lawnmower, because I haven't used it since last year, and it's coming up mower season, lawn mowing season here, which I love. Nothing like jumping on the ride-on for 2 or 3 days and mowing my backyard. Okay, we've got our welded up ham wheel in our Colchester, and what I'd like to do is touch up this front face of the boss. Now I don't know how far we're going to be able to get, because without a doubt this will be really hard where the welding's contacted the cast iron where I need to machine. But I think we'll be able to get some of it off, and at worst, you know, get a couple of tool marks in so we get a circular reference mark to help us when we clean this up with the grinder, you know. So, and it's actually not running that bad really, considering what it's been through, you know. So yeah, let's give it a prod or two with a tool, see how it goes. Okay. We don't need a full cleanup, we just need an established radius, you know, we can grind to, or add a flat face for the washer and nut to pull up on, but that's actually coming up all right. Okay, I'll concentrate more on the this outer bit now. Although, I'll see how it goes, although we can get that with a grinder. We'll go a little bit more. We got it. Okay, let's get her out. Okay, I'll complete all the blending of this and bring you back when we're finished. I've done most of it on the opposite side here. Just needs a final bit of a tizzy up, and of course a bit of blending required in here. As far as that missing spoke, I'm not going to worry about it. We can do without it. There may be one of these in the pipeline as well, so not sure yet, you know, as like the Cross Slide hand wheel, but we're not sure yet. So I'll get this tizzied up and bring you back. And finally, all the welds cleaned up, and that is our finished hand wheel. So we're not going to worry about that missing spoke. There are times when you need to quit while you're ahead, and we are ahead on what we had, you know, what we had to work with. Now, I'll just run through a couple of points through this. So basically, yeah, the way we tackled this with a MIG welder, 100% not recommended practice. But being as this part, there was no structural loading on it. It just has to be together strong enough to be a hand wheel. Now, if this gets a solid bump, it may or may not break, as would be a new one or one that had been welded in a different process. You know, it's one of those things with castings, you don't know. All castings, you know, they're all different in some respect as to how they can be repaired or welded. And my main goal with this, and the driving reason, there's two main driving reasons behind why I did it with the MIG welder. One is cost nothing to do. Now, in that respect, you could spend a lot of money on nickel or bronze and oxyacetylene, because oxyacetylene, in my opinion, is a superior process than electric welding, be it with nickel rods or TIG. You know, the oxyacetylene doesn't have that reaction with the cast iron, in my opinion, on the edge of the joint. You know, the cast iron, when you electric weld it, it tends to go hard and weird, whereas you don't sort of get that effect with oxyacetylene and that. But yeah, it was to keep the cost down to nothing, because the way this was, and you know, you could weld it and then just have it crack straight away when you go to do your repairs on the spokes. So it's an unknown, you know, it's one of those things. It's a gamble. And the other thing why I chose the MIG, I'll just give you a quick glimpse of it. This tray down here, the one that I did a shocking job on colour matching, but it matches the background panel there. This was broken into several pieces. So if we look along the top, that is a weld running all of the way along there, full length of it. There's a triangle piece there. That's not a weld there. That's something, I'm not sure, but it's always been there. So yeah, break there, and across the front here, I can feel it underneath. That corner was snapped out too. So yeah, it was smashed out in several pieces. And when I did this one, I did this with a MIG welder as well. Okay, I tried nickel, I tried bronze, I tried various processes. And the best process was the Eutectic Model B torch with nickel powder. But that's a very expensive repair going that way. Everything else was cracking. Bronze was cracking, everything was cracking. But the best chance that I had without cracks was with MIG. Yeah, it's just one of those strange things where what you don't never do, totally not recommend to practice, works. And once again, this is a non-structural part, I guess, till you drop something on it. But it's got it back together, and we didn't. Well, our option was to remake one out of steel, so that's why we went that route first, and it didn't cost that much to repair. So there were some spots on this where I could do multiple runs, you know, 3 or 4 runs before I stopped and let it cool down. And that was more so, you know, building up, initial build-ups and that. And especially once we got into the center section, it was purely just stringer runs. And a lot of the time, I'd only weld half the distance. Stop, let it cool off, then finish and go the other part of the distance. That being, when it cracked, or if it cracked, it's not a crack completely across. There are cracks in this, but they're all misjoint, you know, they're not meeting up. Like there's one across there. It comes and goes. It's just the way it is. But it should be strong enough for a hand wheel on a lathe. I'm not anticipating any problems, but we shall see. But once again, there is a possibility that I can get another original in the pipeline, but we're not sure yet. We're just waiting to see how that pans out. So, ready for refitment. And all dressed up. Now, to dress it all up, I was just using a ordinary grinding wheel, sanding discs, and these emery paper rolls. A friend of mine over in the USA sent me a heap of these. I think they are available from McMaster Car over there. Okay, so let's get this fitted back on the machine. And it does have a light coating of clear coat on it too, stop it from rusting. Now our screw goes in for the lock for the dial. Nothing wrong with that at all. So as long as no banana and a forklift comes along and ploughs into it, which is very unlikely in my workshop because I do not have a forklift at this stage, that will do. But it looks the part. So next one, we're going to get back onto this one over here. So I think we're going to move the position of this handle to over there. And the other added bonus, all the weld material is the same colour, all matches, and matches the tailstock one. Beautiful. So we're back on our cross slide hand wheel, and yeah, we need to move this knob from there to there because that just ain't right. That's wrong. Yeah. So we're going to use this end mill, and we'll just machine in a bit of a flat land. So when we drill and tap it, the little handle has something flat to pull up on, hopefully. It's chrome, it's carbide end mill, but it's been around the block a few times, so we'll just see how it goes. Just come up on the table slowly. She's a bit of a squealer. Only at the end though. No, that might be enough, I think. Let's have a look. Get a measurement. We've got about 16 mil on the seat of our knob. Just go a fraction deeper and we'll just go a fraction deeper. Yeah, that'll do it. I dropped the table down right when we're at the end of the cut. That way we keep centered. So I'll swap over now for a drill bit and we automatically will be on center. Okay, spot drill. 8.5mm tapping drill. Oops, bumped the camera. Drills like ordinary cast iron, not like that Dean Smith and Gray stuff. Okay, we'll put our tap in. We might be through there. Oh, I hear more, eh? Definitely through there. Okay, back her out. Get our tap out the way. If I cleaned it out and had a bit more room to grab it, that'll be fine. What I may have to do is just put a 3/8 drill in. I'm just checking to see if it screws all the way down or I've got to machine a spacer. You know, I'll put a 3/8 drill in and I'll just knock off the first couple of threads. Yeah, because there's no real relief at the last couple of threads. That's what they've done on the other side, so I'll do that. Yeah, just want to remove those first couple of threads. Get it back running the right way. Like that. That's all it needs. Okay, let's get her out. So you can just see we relieved the first couple of threads so our handle can screw down flush. We will have to remove this chrome. It's just flaking off. Okay, I've removed the chrome off the hand wheel and just tizzied up the radius on the corners. It's only just temporarily fitted at the moment. Due to the fact that the main cross screw shaft has to come out yet, but it sort of looks the part. I'll tell you what, it could be a darn sight worse, you know, but it does, you know, the counterweighted section does sort of match the DSG one, and it's not so queer looking now that we have its knob on the right end of it. So happy with that. So not much left to go on this assembly here, being has top slides already completed. The major job left on here is the cross slide feed screw. I've got the gib strip out of this at the moment, but this is all ready for reassembly. Yeah, so I'll just come around from the other side. Yeah, so I'm just working out what I'm going to do. I don't want to let this nut go with the amount of backlash that's in it, being as we've done our best to get everything else as good as we can. So I'm going to go ahead with the idea of cutting a thread in here to match our thread here, attaching this on the back with shims and 2 cap screws, and it will act as an an adjustable nut, you know. So that's the plan for that. All right, we'll bring this one to a close here. So yeah, great progress. So yeah, I think next time we'll have a bit of an assembly session. We can get our cross slide all on properly, shimmed up, top slide on. We might even look at the tool post, and then we'll sort out exactly what we're going to do with this thread. Whether I set it up in the lathe or the optical comparator. I want to measure exactly how much wear is in it, you know. I'm not going to make a new one, but there's a possibility I might machine the wear out of it if it's a bit too excessive. It'll mean the main nut will be a bit sloppy, but that won't matter because the slop will be taken up by our adjuster nut, if all goes according to plan. So that's the plan, Stan. So, all right. Before I go, remember a couple of videos back, I had a shot at the end of the video, a scribe mark on my wall, and then down on the bench there was a pointer thing. And yeah, a couple of people knew what I was on about, but for those that didn't, I'll show you what it is. So I actually need to make a proper one. So what it should be is a piece of steel flat bar with an L-shaped on the base of it to hold the pointer. So the pointer just sort of sits there in the center of it. So it's for sharpening, checking your drill bits. So when you sharpen your drill bit, that is for getting the correct angle. That was one that I made when I was a first year apprentice. One of the first things we made. And so you can sharpen your drill bit to the angle of the gauge. But the only problem with that, when you go to do the other side, how do you know that that edge there is on the same height as that edge there, you know? Because if they're different, if that's lower than that, your web on the end of the drill won't be central. So what you do is you put, now most drill bits, they've got a center in the end. So you just locate the center in there. I'll just move the camera and give you a closer shot of this. So without moving the center, you scribe a line from the very corner of your drill, like that. Rotate your drill 180 degrees and scribe another line. Now those two lines should line up. But as you can see there, we have two scribe lines. So our drill grind is a hair off what it should be. So that'll make it cut on one side as well more than the other. But yeah, one day I'll make up the proper thing so I'm not using my wall column. But basically that's what it's for. Yeah, just to make sure your edges are all true to each other, and after you've ground the angle. So what I would have to do, what I would do here, being as one was higher, or one, the second scribe came in just underneath, I would then go back to the grinder and grind a bit off the opposite side until they scribed one line. That's that. Well, okay. Hope you got something out of that. But it's a good method for doing your drill bits, especially the larger ones, you know. So, all right. So, another bit of useless information. So, okay. Cheers.